All right, so let's look at a couple more examples here. More of the same as what we did on the last one. So we have x squared minus 4x plus 4 over x squared minus 1. We're just going to do the same steps. So the first step is always to factor the numerator, factor the denominator. In this case, we have x minus 2 squared, and on the bottom we have x plus 1, x minus 1. And then we're going to find the x-intercept, the y-intercept. We're going to find the vertical asymptote, or actually, we'll put the horizontal asymptote up here and the vertical asymptote down here. And the reason for that, to get the x-intercept, you set the numerator equal to 0. To get the vertical asymptote, you set the denominator equal to 0. So the only x-intercept we have, set this part equal to 0, and we get x equals 2, so 2, 0. The y-intercept, remember you plug in 0 for x, and we're just left with 4 over negative 1, so that'd be 0 and negative 4. Horizontal asymptote, the degree on top is 2, the degree on bottom is 2. So the coefficients are 1 and 1, so that means we have a horizontal asymptote at y equals 1. And then the vertical asymptote, set the denominator equal to 0, and we get x equals negative 1, x equals 1. So now we can start to plot these points, draw our asymptotes, and then see where we get. So there is our x-intercept. Here is our, the y-intercept, not the y, or the horizontal asymptote. We have a horizontal asymptote at y equals 1. And we have vertical asymptotes at x equals 1 and x equals negative 1. And so now it's just a matter of seeing where everything goes. So like we did last time, let's pick numbers on either side of each of the vertical asymptotes. So let's try x equals negative 1.1, just to the left of x equals negative 1. So now in this one, notice the numerator is always going to be positive because we're squaring that. So we don't really have to worry about that. That one's always positive. So really we're just worried about what is the sign of the denominator. That will dictate the sign of the rational function. And so let's see, we have plugging negative 1.1, we have a negative and a negative. So negative and a negative, so this is going to be positive. So what that means is we are going to come up like that. Now come on the other side of negative 1, so let's try negative 0.9. Again, the numerator is positive. Negative 0.9, that will be positive, and then negative 0.9 in there, that will be negative, so this one is negative. And we know it's going to come to that. And we don't know, like I said in the last one, you can't, there's no way to tell just guessing. I mean, either it's going to come up like that, or it's going to come, actually, there's no intercept here. So it's not going to cross. So we're going to go ahead and say it's going to come down like that because it's not going to, there's no x-intercept between 0 and 1. But we can test it out. Try 0.9, positive on top because of the square, 0.9, and negative. So positive and a negative, that's going to be negative. So it goes down just like we said. Now in this case, it could come down like this and then come back up to the asymptote. That is possible, but probably it's going to come up like this, probably. But let's try 1.1 and positive on top, positive there, greater than 0. And that's what it does. So it does come down like that, touches now it does touch. So that's another, actually, we probably could have figured that out because we know that from an earlier section that when the multiplicity of this 0 is 2, so that's even, that means it's going to touch the axis. So we should have known if we were paying attention. It's not going to come up like this and cross. It has to come down, or it's not going to cross, it's going to touch. So in this case, because we know it's going to end up coming like that, has the touch there, so it has to be coming down like that. But so there are two ways to figure that out, either from noticing that or just plugging in some numbers and seeing what sign we get. All right, so what is the domain? The domain, as always with these, we're just going to take out where the denominator equals 0. So in this case, -1 and 1. And we end up with this. And then the range, now the range is not all real numbers like it was in the last one. Start at the bottom, these go down to -infinity. So we can start from -infinity, we're going up to -4. Now this one has a bracket because this is not an asymptote. If it's approaching an asymptote, then it may or may not include that asymptote. But if it's coming up to an intercept, then it does include that. So then union, and now we have a start here. So that'd be at y equals 0, and that would be a bracket because we do have that point to 0 that is part of the graph. And then it's going to go up to infinity. So with range, you got to be a little bit careful. You definitely need to graph it first. With the domain, you don't really have to graph it first. You can just set the denominator equal to 0, and that's really all you need. You take out those points, and then everything else is in the domain. But the range, like I said in the last one, it really could be almost anything. All right, a couple more here, and these are a little bit simpler. So we're going to start by factoring, and numerator does not factor the denominator. We can factor out an x, and then we see that those will cancel out, and we have a 1 over x is what we're left with. And we already know what that one looks like. We did that on the very first page. We saw that graph. And now the only thing you got to pay attention to, what is the domain of this? Like I said, to find the domain, you set the original equal to 0. We're not setting this one equal to 0. We're setting this one equal to 0 because this is the function that we're talking about. So we set that equal to 0 and solve for x. And of course, we get x equals 0, x equals 3. Now the x minus 3 factor, it was eliminated, but you still have to consider that in the domain. So this will be a vertical asymptote. This one, the factor that canceled out, that's going to be a hole in the graph. And so basically what we're going to do is we're going to draw the graph of 1 over x, but we're going to take out 1 point. And so when x equals 3, we can plug that into this. That means that y is 1/3. And so let's figure out where that is. This part's going to look the same. That's just a 1 over x graph. This part, we're going to come down. But then when we get here, let's draw an open circle because we're taking that point out. And it looks like that. So with the exception of that part, this is the graph of 1 over x. But the point, so that point is 3 1/3. There is a hole there because that factor came out. And so we're just removing that little point from the graph, and everything else looks the same as if it was 1 over x, but except 3 is not in the domain. So we're just pulling that point out. So whenever you factor a rational function, if a factor cancels, that will represent a hole in the graph, not an asymptote. So the only asymptotes are the ones that are left over in the simplified form that would make the denominator be 0. All right, so let's see one more. And let's look at this one. So this one, factor x squared out of the numerator. And we're left with x squared times x minus 2. The x minus 2's cancel. And so this one, actually, this equals x squared. And x equals 2 is a hole because it canceled out. So the domain is all real numbers except for 2 because that would make the denominator be 0, but there's no asymptote. And this one is just going to look like y equals x squared, except we need to take out that point where x equals 2, which means that y equals 4. And so let's just kind of draw this like that. And there is a hole right there. And we're going to say that that is 2, 4. And it looks like that. Okay, so then if you want the domain and range, we could have done this on the last one as well. But the domain of this is negative infinity to 2. We're just taking out that 1.2. And then the range, start at 0. And then we're, well, 4, actually 4 is in the range still because it's over here. So actually it'd be 0 to infinity still because you can set that equal to 0. So well, you find out if a number is in the range, set it equal to the function, see if you can get an x that solves that, and x equals negative 2 does solve it. So so 4 is in the range. Okay, so those take a little bit of practice. It's a lot of the same things over and over again through the homework. So watch these examples and then practice in the homework, and you should be able to get it. So it's pretty repetitious in that way.